So the given equation here has roots alpha, beta, and gamma, and we need to show that this equation here has these roots, which is 3 alpha minus 1, 3 beta minus 1, 3 gamma minus 1. So the best way to go about it is to use the given equation here. So that is what you are going to use to show for this. Okay, so solution. Now remember, we have the given equation that has alpha, beta, and gamma as the roots to be 9x cubed minus 9x squared plus x minus 2 equals 0. Alright, so don't forget the root of this equation given to be alpha, beta, and gamma. Now in this case, now the new root, which is 3 alpha minus 1, we can write that to be y equals 3x minus 1. So I'm sure you are not new to this already. Each of the roots of this equation represents x value. Okay, so we take our new roots now to be y. So what are you going to do here? You simply make x as a subject, and that becomes x equals y plus 1 over 3. So let me call this to be equation 1, and let's call this to be equation 2. Alright, so when you make substitution of 2 in 3, substitute 2 in 3, so you have 9 in brackets y plus 1 over 3, all cubed, minus 9 y plus 1 over 3, all squared, then plus y plus 1 over 3, then minus 2 equals 0. So let's simplify what we have in the brackets first, which is 9 y plus 1 cubed. I'm sure that's going to give us y cubed plus 3y squared plus 3y plus 1, and 3 cubed is going to give us 27. Okay, then minus 9. So when you simplify y plus 1 or you expand that, that's going to give you y squared plus 2y plus 1 over 9. Okay, so the reason why I don't have to show the workings, as a mathematician or as a Cambridge further maths student, you should know how to do this already. So this is going to save you time. So there is no mark for that, for showing how we obtain that. Alright, so this is y plus 1 over 3, then minus 2 equals 0. So and again, in simplest sum, the first term can be written as y cubed plus 3y squared plus 3y plus 1 over 9 in 27 will give us 3. Then the other one, this 9 here cancel this, then you have y squared plus 2y plus 1. Then this must be in brackets because of minus. Then you have y plus 1 over 3 minus 2. So we need to take LCM of this, or you multiply all 2 by 3. So you multiply everything here by 3, that's going to be y cubed plus 3y squared plus 3y plus 1, then minus 3y squared. Now I'm using minus 3 to expand this second term now. So minus 3y squared, then minus 6y minus 3. Then this remains as y plus 1, and now this becomes 6 equals 0. Okay, so when you arrange that now and write your answer in simplest sum, that's going to be now 3y squared here takes minus 3y squared. So which other terms are going to cancel out here? So we have 3y and y, that's 4y, then minus 6y, that becomes minus 2y. Okay, then we have 1 minus 3 and minus 6. So that's going to give us y cubed minus 2y, then minus 7. Okay, because minus 3 minus 6 is going to give us minus 9. Then we have plus 1 here, we have another plus 1 here, that's 2 minus 9, that's going to give us minus 7 equals 0. So, and that is what you have to show. Now the second part of the question is to find the value of x subscript 3. Okay, x subscript 3. Now you have to be very careful here. Xn here is for the second equation. Okay, xn here is not meant for the given equation. So xn or x3, let me repeat, is meant for the second equation here. Okay, so whatever you are going to use as x3 is going to be from the second equation we just obtained now. Okay, so x3 now, to get that, we can actually change this to the current formula of this. That's going to be x3 minus 2x1 then minus 21 equals 0. Okay, so x1 of this is going to be x1 there is 0. Okay, x1, when x1 is 0 now, so make the substitution here. You have x3 minus 2 times 0 then minus 21 equals 0. So x3 equals 21. So, and that is the final answer there. Okay, I think the second part of the question, okay, the third part, find the value of x substitute minus 2. Okay, so x substitute minus 2. Now to get that, let's go back to the derived equation. Let me call that to be equation 3. So from 3, our y cubed minus 2y minus 7 equals 0. Okay, so for us to get x substitute minus 2, we can actually divide both sides by y cubed. Okay, or we divide both sides by y squared. I divide both sides by y squared. This becomes y minus 2 over y, then minus 7 over y squared. And the recurring formula for this is going to be x1 then minus 2x subscript minus 1 then minus 7x subscript minus 2. Okay, so if you don't know how we obtain this, you better go and watch one of my videos on what's it called, roots of polynomial. So you are advisable to do that before you continue with this. Okay, now essentially we are asked to find x subscript minus 2, and again, to get this, we definitely need the value for x1, which we have that to be 0 already. Then x subscript minus 1, we need the value for that. Okay, so that's x subscript minus 1. Okay, let me start with x1. We have x1 to be 0. X subscript minus 1 is the ratio of the linear terms. Okay, the ratio of the linear term here is going to be x subscript minus negative of the ratios. So that's minus 2 over 7 minus 2 over 7. Okay, so make the substitution there. We have 0 minus 2 times minus 2 over 7. Then minus 7x substitute minus 2 equals 0. So you therefore have x substitute minus 2 to be 4 over 49. And that's the final answer to that question. Okay, and that's the end of the class.